Next Curve.
Hey everyone, welcome to Next Curve's reThink webcast and our Analyst Corner. And I'm Leonard Lee, Executive Analyst at Next Curve. And this is a new episode of Silicon Futures where we cover the stuff happening in the semiconductor industry that matters, totally disregarding all the stuff that doesn't matter. And I'm here with my good buddy, Karl Freund, founder and principal analyst at Cambrian-AI Research LLC. And there's a hyphen there, right? Right, Karl? How's it going?
Yeah, I'm going great. How about you?
I'm doing okay. You know, I'm trying to detach myself from the metaverse over here occasionally.
Yeah, I saw that back there. I'm jealous. I've got a Quest 3, so I'm
yeah. So yeah, I got the Mac back there, and then I have the Vision Pro. But anyway,
the contrast between the two is pretty striking, isn't it?
Yeah. So for those of you joining us here in this discussion, Karl is a leading analyst covering the semiconductor industry, and we're collaborating on this series that focuses on AI in the semiconductor industry, and it's kind of like the big thing, right, these days. In this episode, we're going to be talking about this whole trend toward custom designed chips, right? In particular, as it relates to a lot of the accelerated computing that's going on and is kind of in vogue at the moment. So, hey, Karl, you wrote this really great article in Forbes talking about
Thank you.
Various dynamics that are playing out and kind of things that are moving in the industry around this custom trend, or at least providing some evidence that there is this I guess push toward custom in the industry. So, I mean, what are some of your thoughts there that you'd like to share?
A lot has been said and written about chiplets, right? As a new technology. Not much has been said or written about the business models that are now becoming possible because of chiplet technology. If you look at the customization market, people like AMD building chips for Sony and Microsoft, and Nvidia doing the same for its gaming platform with Nintendo. But the chiplet, the rise of chiplets changes all that, right? So instead of doing an IP transaction, you can actually sell a partner a component which then can be integrated either by the semiconductor vendor or their customer into a bespoke solution for a specific problem. Tenstorm, for example, they've done a pivot from, we're going to go beat up Nvidia with a faster AI accelerator to, we've got all this technology that we can make available to you, and you can embed it in your car, you can embed it in your television or other consumer electronics device, and have it be specific. And the advantages of the specific are you've got the performance you need, the right type of performance you need, because maybe you need 16-bit, maybe you need 8-bit, maybe you make do with 4-bit, and that makes a massive difference in cost and performance. And that's all critical for the custom business, because you've got to be able to scale it, right? You're not going to make a lot of money selling and getting into a custom business for somebody who just wants a couple 100,000 units. So this has to have significant scale. At the same time, you've got people, all the cloud service providers. They love and they hate NVIDIA, right? They love their chip, but they're envious of the margin they're enabling for Jensen Huang that they would like to capture themselves, right? And so you've got everything from Microsoft Azure Maya to Trainium at AWS. You've got Google TPU. Let's take a look at Google TPU for just a moment. Right, Google TPU was actually built built maybe an overstatement, but by Broadcom,
Right.
right?
Yeah.
Right. Broadcom does the back end work for Google. Google does the design work. They say here's the logic of the chip. You guys go build the chip, all right? And then they tape it out to TSMC. I'm not sure who does the actual tape out. I suspect it's Broadcom, but so it's a trend in the industry. It has a lot of money behind it right now. I mean, Broadcom's doing about $10 billion a year in custom silicon designs. Marvell is doing about $2 billion, but it's the fastest growing part of their business right now, as they provide IP. Tenstorrent is coming out of the woodwork with all kinds of design wins. Everybody wants a chip that's been designed by Jim Keller, right? He's the best chip designer on the planet, people say, and who am I to disagree? And so
I'm not going to disagree.
I'm not going to disagree. He's done great chips from Apple to Epic.
Yeah.
And now he's building both CPUs with RISC-V, and he's building AI engines. They just released a new Grayskull ASIC for AI. It just comes on a little PCIe card, very inexpensive. And there's my little puppy dog.
I know. That's great.
She'll hop up on the chair back here. There she is. Yeah. Hi, Daisy.
Keep an eye on her. Sure you don't
she wants to be a star. Anyway, there's definitely something there. So NVIDIA, this is according to Reuters, right? And NVIDIA has not confirmed any of this.
Yeah.
But NVIDIA has decided that all these people building chips to compete with them, we can help you with that.
Sure.
It's not that they're going to stop buying H100s anytime soon, or B100s later this year. They will, because that's what the market demands. But for specific applications, NVIDIA has IP. It's interesting. This is why they were going to buy ARM, right?
Yeah, and you're bringing up a very interesting point. But here's the thing. I mean, if you look at a lot of the different trends and hype cycles that NVIDIA has ridden, whether it's AI, X minus 2, 3, 4, or whatever you want to call it, or the crypto or the metaverse and all these things, what we've seen is their whole, call it AI stack, is sort of a general, it's built off of a general purpose concept, right? Software defined general purpose, CUDA, that allows a GPU now to be able to be used across a wide range of different use cases, right? Mm-hmm. And then there's always at some point a transition toward ASICs, right? So we saw that with crypto. People were buying up Nvidia GPUs like crazy initially, and then they realized, wow, this is getting kind of expensive, and it's not as performant as if we just did designed and deployed an ASIC, right? That is tuned specifically for this kind of workload. And I think we're starting to see that, and you're hearing a lot more about it. ASICs that are geared specifically toward a certain LLM and generative AI application, or even AI stack. And so I think that's what that's that play that we're seeing with the hyperscalers, where they're saying, look, we have the scale in terms of end market demand. Why are we paying NVIDIA a huge premium when we could probably do it ourselves at a much lower cost using purpose-built chips or purpose-designed chips? But the dilemma for them is all of them are talking about how they're going to support hundreds of different types of models, and how do you reconcile that? I think that's going to be a really interesting thing going forward, and it may kind of be a headwind to this whole ASIC, move to ASIC trend, But
well, it's bad. I mean, if you're building a robot, and let's say you're going to charge $10,000 for the robot, how much can you afford for the GPU inside that robot? You can't afford $10,000 for a $10,000 robot, right?
Yeah.
Just for the GPU. And so you need to have an ASIC, and you gotta believe you're gonna have enough volume to justify the expense of developing the ASIC. So now you have a choice. You can go hire and build the expertise internally and design, and this is all going to take you at least 3 years.
Sure.
To build it, because you don't have the expertise. You're a robot manufacturer, right? So to continue the analogy, the alternative is to say, here's what I have to contribute. Okay, we really understand, let's say, robots' abilities to sense pressure and things like that. We've got all that, all the sensors. We got the sensors.
Right.
I need a chip that will do this, this, and this. I'm going to spend this much money. It's got to have this much performance, this much latency.
Yeah.
Well, then you can go out and shop it around. Now you can go to Tenstorrent. You can go to Nvidia. At one point, you can go to Intel. Not clear that they're going to get back into that model, that market. You go to Broadcom, go to Marvell, go to lots of different companies, and assess their ability to meet your needs. Yeah. And what it's going to cost you, and how long it's going to take, and what's the NRE, right? So you can build the chip, right? So now you've got, with Nvidia jumping into the fray, if Reuters is right, and I don't know if they are or not, but let's assume they are. Yeah. They had like a dozen different people from Nvidia confirming the story, so it's probably right. Mm. You now have access to maybe not the world's leading AI technology, but at least N-1 or N-2, right? That's technology that's just sitting on the shelf in NVIDIA's virtual machine here, and they can now monetize that. I always said that people say, well, why is NVIDIA looking to acquire ARM? And that's just because they want to monetize that which they do not want to productize. Mm. Okay, and so now you've got a business model that allow you to make more money out of stuff you're probably not going to sell as a product. As well as, important for NVIDIA, you can blunt the impact of substitution if Microsoft or AWS or somebody else wants to build a next gen chip, you could actually make some money off that. Yeah, and very high margin. Right, not as much as selling a $30,000 H100, but you're going to sell those anyway. So this is for something else, right? Yeah. And I always saw Nvidia's bid to acquire ARM as kind of an XPU type of move, right? It was actually not about necessarily the licensing piece. I mean, one of the challenges of the deal would be, how do you create sort of a firewall between, the markets that you compete in with ARM's customers, right? And, at the end of the day, what they ended up doing is what I wrote about actually at the time, that, Grace Project Grace. I mean, what are they doing now? They're gonna be releasing Grace Hopper, right? They're gonna be getting into a head-to-head competition with Intel across portfolio, right? So it in a lot of ways, I think being on their own or being without ARM, who they partner with heavily anyways, right? They're positioned well at the moment to now, really shed that GPU branding and then taking things, I think, to the next level, right? So they're becoming more of what like ARM's oftentimes talks about, heterogeneous computing company, right? Where, like you were saying, all these different types of IPs coming together to define what the next generation of computing is going to be. And, Nvidia likes to call it accelerated computing, right? Isn't that what Jensen talks about all the time? And he talks about how, accelerated computing is going to take over the world. It's like, yeah, okay, sure. But that doesn't mean that it's going to be all GPU, right? I think when you talk about accelerated computing, it's basically an evolution of this concept of, CPU and
CPU-centric thinking, more toward an XPU kind of thinking, and looking at how applications are evolving where you're blending AI-ish kind of stuff, augmenting traditional things. And that's what we're seeing even with generative AI, right? A lot of the applications out there are not a standalone large language model type apps. They're usually chatbots that are based on some sort of RAG architecture. And so when you look at graph databases and vector databases that underlie these systems, GPUs aren't entirely tuned for the entire stack, right? And so you have to have a mix of computing IP that are optimized for different aspects and functions and workloads of that system. And I think that's really what's where Nvidia and others are evolving toward. But I think Nvidia is going through an interesting transformation, but I think they're kind of circling back toward where Intel already is. Do you know what I'm saying? It's just, I don't think people are so enamored with the AI narrative right now. I don't think that they appreciate where Intel and arguably AMD are, right? Because for the most part, I think Nvidia is still largely regarded as a GPU-ish kind of company, right? I mean, correct me if I'm wrong. I mean,
well, I think you're right. I think that they're on a glide path, though, to becoming a system company.
Yes,
not a chip company.
Yeah,
and so whether it's a CPU or a GPU or an integrated CPU and GPU or an integrated CPU and GPU and NPU, right? They're going to take. I mean, silicon's always been about take the various components you did last year and integrate them up and integrate them up and integrate them up. Well, it's getting to the point now that that level of integration is a full system, out, including in some cases memory. I mean, Grok has memory on chip, right? Cerebrus has memory on chip or on wafer. So again, that level of integration continues to rise, and that creates opportunity for differentiation.
Yeah,
it depends on what technology you're integrating. So now, flip over to the guy who's saying, "I don't need all that crap. I just need it's good crap. I like it, but it's not what I need for my robot or my computer vision device that's going to have to cost less than $500." I just need really good computer vision. I don't need large language models, and I won't pay for all the memory that a large language model consumes. I just need really fast compute vision. There's still a market there for that.
Yeah.
And that's where companies like TensorTorrent and Nvidia have, and Marvell and Broadcom come and say, yeah, we can do that. There's also an area where Synopsys and Cadence have a lot to say and play. They have, it's interesting, SEMA.ai, I'm not sure you're familiar with them. They've got a low-end edge AI accelerator, right? And it's got a lot of different componentry on it, and one of them is an image processor from Synopsys. Right? Yeah, they just bought it. They just integrated it into their SoC and said, "Well, we can't design a better image processor than what Synopsys already sells as hardened IP that I can just drop into my SoC. I can get to market faster. I can lower costs. By the way, I'll have better performance." So it gives you a broader market access to more technology by tapping into someone's already existing technologies. And it could well be the future of the semiconductor industry. I mean, it could be that big. Maybe $30 billion is the data center only custom silicon market. That's pretty big. And it's growing very rapidly, excess of 20% CAGR.
Yeah, so in that 30, because I'm always curious when these numbers come out. It's like, well, what are you including in there, and is it displacing existing demand, because obviously if the hyperscalers start to really bank on their own silicon and their own stacks, whether it's sort of more of a general purpose or sort of app or LLM specific, what does that take away from like the AMDs and the Nvidias of the world, right? Who are right now shipping the most silicon into the market, right?
And a lot of these will come at the expense of FPGA, honestly, because FPGAs are great. You can do anything you want with an FPGA, as long as you have the programming skills to make it sing and dance.
Yeah,
and not many people do, right? Robotics manufacturers, for example, they're actually already in the FPGAs. Yeah. But if they can get to market faster with a better product at lower cost, they'll jump on it.
Right. Well, I mean, if there is a market fit for whatever custom ASIC that they've kind of configured and modeled in an FPGA, that's where they'll trigger that transition to an ASIC design, right? If there's
only if they have enough volume,
enough of a market there, like you were mentioning before.
But if it costs $15 million to take something out, and you don't have enough volume to recoup that NRE, then you'll just stay on FPGA. That'll be your delivery platform, not just your development modeling platform.
But wouldn't you say
that's why AMD acquired Xilinx?
But I mean, I kind of see like Nvidia's stack as kind of it being a software defined like FPGA type thing, right?
Yeah.
Instead of being able to configure at the hardware level, you're taking a GPU and using a software abstraction so that you can kind of do the same thing, right? I mean, in a way, right? At the application level, and where the FPGA, maybe it's a couple of levels lower, but it provides you with that kind of flexibility that the NVIDIA, the NVIDIA stack provides, Yeah,
that's a really good point. That's a really good point.
Yeah, in fact, even to developers. So if we talk about why NVIDIA's stack is so compelling to the end market, is really because it probably makes it simpler than any other option out there right now for the developer, right?
Absolutely. I agree. Good point.
Ah, Jesus.
There we go, agreeing again.
What's wrong with you?
We're supposed to be disagreeing.
No, I know. We're just like riffing off of each other. So upsetting. But no, there's a lot to think about. I'm sure when we listen back on this episode, you and I will probably come up with some additional interesting perspectives. But yeah, I'll have to say the semiconductor industry has become very, very exciting, but also incredibly competitive, and all the different vectors of that competitive dynamic are just incredibly interesting, but I think difficult to tune into. You know what I'm saying? I think I think certain narratives have more gravity than they really should, and but regardless, reality will rule, and we'll see a balancing of things as one hype goes from here to there. You know what I'm saying?
Yeah. Well, when it comes to customization, my advice is just follow the bouncing ball that's got all the money in it. Right. Tenstor's already got some very large contracts in Korea. That's just one country. Yeah. Right. They haven't penetrated Japan yet, or at least not with any public announcements, or the West.
Yeah.
And so I think that the scalability of custom semiconductor business is going to become the issue.
Yeah.
You really can't afford to do total top to bottom custom semiconductors. What you need to do is be in the building block business. That's what Tenstor is doing. I suspect that's what Nvidia is doing, although, again, hopefully we'll hear more about this at GTC or shortly thereafter. Maybe the fall GTC, we'll start hearing more about it.
But yeah, your comments about chiplets and how it's impacting the economics, I think definitely spot on.
The challenge with chiplets is one of governance, right?
Yeah.
If you solve UCIe and everything, will solve the electrical connections and all that stuff. But if you've got a chip and it's got a problem, how do you know whether it's your IP or your IP provider's IP that's at fault here?
That's why the EDA guys are going to make a crap ton of money.
I think so. I mean,
cost goes up somewhere.
Cost goes up somewhere, and I think Cadence and Synopsys have a good handle on it. Of how to deliver the IP in a way that's dependable, and the governance is not an ornery problem left to the customer to understand and solve.
Yeah. Well, hey, a lot to think about. It was great to jump on the podcast here with you, Karl. I had no idea how this is going to turn out, but I think we managed to share some interesting perspectives with our audience. Hopefully they enjoyed it and found it informative. And why don't you take a moment to tell our audience how to get in touch with you as well?
Sure.
Tap in.
Yeah. Just go to www.cambrian-ai.com and you'll see all my articles and research we've done, as well as ways to contact me, my team. So it's a very small team, but very proud of what we, under Daisy's guidance, that we can pull together for our clients.
Operations officer. Yeah.
And of course, follow me on social media and on Forbes. It's my primary publication outlet.
Yeah, and check out his article. It's really good. I had a chance to take a look at it.
And if you don't have a Forbes subscription, you can always find the same article on my website 5 days after I published on Forbes.
There you go. So,
there you go.
And thanks for tuning in, everyone. Please subscribe to the Next Curve YouTube channel. Hit that like button, subscribe, and share. But most importantly, comment, share your thoughts, your reactions, and we'd love to learn from you.
Yeah, I'd love to hear your comments on this conversation.
Yeah, definitely. And the easiest thing to do is subscribe to the Next Curve Research Portal and Media Center at www.next-curve.com for a constant diet of the tech and industry insights that matter. And we will see you next time.